Namaskar. It gives me immense pleasure to introduce you to the Indian Plumbing Association's Plumb Talk series. As part of Plumb Talk, plumbing industry experts from across the country will be explaining the nuances of plumbing technology in an easy and understandable manner. And this will make plumbing science easier for building industry professionals, engineering and architectural students, as well as the general public to understand the basics of plumbing technology. Let me give you a little background on IPA, which is the apex body of plumbing professionals in India. IPA is now a 29-year-old body started in 1993, currently has 24 chapters working towards redefining plumbing standards in India, tirelessly working towards better plumbing for a healthy living. I therefore request you to please go through the Plumb Talk series, which will be a guide for students, for architectural students, for even current architects and engineers, so that you are able to improve your knowledge on plumbing and ensure that all plumbing installations are installed not only as per codes, but we make sure that whatever water we use, we move towards net zero water and net zero sanitary.
Hello everyone, welcome to Plumb Talk series. Today we will be glancing through water supply, that is chapter 4 from Indian Plumbing Association's publication, A Guide to Good Plumbing Practices. Water plays a prominent role in our life and is also considered as one of the basic needs essential for living. Water covers about 70% of our Earth's surface and is the most precious natural resource that exists on our planet. But out of the 70%, only 3% of the water is fresh water. It is unfortunate that the water which supports all the terrestrial as well as aquatic life is so scarce in our planet. So, while the entire globe is experiencing fresh water crisis, let us take a step in understanding the efficient way of water utilization through today's core topic, water supply. Water supply in simple terms can be defined as the service that provides safe potable water at adequate pressures and quantities to the desired locations within a building. Planning of water supply for a building basically involves following considerations: estimation of daily water requirement, water sources, quality of water and its treatment, water storage, water distribution, hot water generation and distribution, and finally the safety measures in water distribution. Let's go through each of these considerations one by one. First thing is estimation of daily water requirement. Estimation of daily water requirement is the primary step in designing of a plumbing system. Various plumbing codes, standards and other publications provide different data which needs to be evaluated for specific applications. In addition to the published data, experienced engineers involved in the operation of large properties such as hotels, hospitals, commercials or residential complexes and mixed occupancy buildings maintain their own data which may vary from the published data. Plumbing engineers generally rely upon the stipulations of the National Building Code of India published by BIS for per capita daily consumption. For example, NBC recommends 135 liters per capita per day for a residential building, 45 liters per capita per day for a commercial building or office complex, so on and so forth. Where alternative water source is available, 1/3 of this quantum used for flushing purpose shall be from that source to reduce burden on freshwater source. The second important step in assessing probable daily water consumption is the estimation of occupancy levels of the building under consideration. In the case of single family residential unit, the standard method of calculation will be 5 occupants per unit. In the case of high-end residence, additional occupancy may be considered for domestic staff. Occupancies in office complexes are generally calculated considering 1 person per 10 square meters of built-up area. unless otherwise defined by the end users. The second point is on water sources. Sources of water are generally from government agencies, public utilities, on-site open wells, bore wells, rivers, lakes, etc. Alternate source of water may include harvested rainwater, recycled or reclaimed wastewater from treatment plants. Catchment area of rainwater for reuse within buildings should be restricted to the rooftops. Provisions shall be made for flushing away water collected during initial rains. Rainwater harvested from lawns, building surroundings, roof gardens, balconies, etc. may be used for recharging the groundwater table through recharge pits. Use of alternative water, that's recycled water from STP, for flushing is not recommended in hospitals and other healthcare facilities. When treated effluent is used for landscaping purposes in premises used by children such as schools, additional precautions like color coding of pipes, visible identifications, labels, lockable draft taps to prevent unauthorized or unintended usage shall be strictly implemented. Modern plumbing codes such as UIPCI, that's Uniform Illustrated Plumbing Code of India, provide required information on stringent precautions to be taken while using alternative water sources in any kind of premise. The third aspect is quality of water and treatment. Quality of available water source should be established through a test report obtained from a recognized laboratory. The extent of treatment shall be determined based on the quality of source water. So, the treatment may include sand filtration to remove suspended solids, activated carbon filter to remove color and odor, softener to remove hardness, and finally disinfection, which is combination of or individually chlorination, ozonization, UV, etc. to remove the bacteria in water. Modern technologies are currently available to treat several impurities through single equipment. Expert advice shall always be sought on selection of appropriate technologies, equipment. Domestic water purifiers incorporating various technologies are currently available like the cartridge filter, the carbon filter, ultraviolet treatment, the reverse osmosis and the combination of all the above. These are generally installed at the point of usage. Coming to the fourth point, which is water storage. Once the per capita consumption and the occupancy are established, the next step is to determine the storage capacities. Water storage facility is an essential component because the supply of water from government agencies or public utilities will usually be intermittent and often unreliable. On-site water sources such as open wells and bore wells, etc., if any, and their yields and quality should also be the determining factors. It is a common practice to use alternative water source for non-potable applications in order to conserve the available potable water. It is a mandate for large properties as per prevailing statutory regulations to use alternate water sources. Consequently, dual piping system shall be required. Alternative water sources can be used for applications such as flushing of toilets and urinals, landscape irrigation, makeup water for HVAC equipment, etc. and may include harvested rainwater, treated effluent from sewage treatment plants, untreated or partially treated well water, etc. Based on various sources and reliability of water available, storage compartments of adequate capacities shall be provided. Proper sanitary separation shall be ensured between the compartments storing potable and non-potable water. Each type of water shall be provided with 2 compartments which can be independently used isolated. Each tank compartment shall be provided with pipework including inlets, outlets, drain, overflow and vents with insect screens. Provisions for level indicators, level controllers, etc. A freeboard, that's the vertical distance between soffit of the tank and top water level of 200 to 300 mm shall be provided for installation of float valve, overflow pipe, etc. Each tank compartment shall have manual openings of appropriate sizes and numbers, sumps at the base of draining the tank. Additional sumps may be required in specific instances for installation of submersible pumps. Minimum size of manhole opening shall be 560 mm dia or 600 by 600 mm. Number of manholes shall be dependent on the length of the compartment. However, a minimum of 2 manholes at diagonally opposite ends are recommended for safety reasons.
Manhole covers shall be airtight and lockable where required. Selection of manhole covers shall also take into consideration the expected loading factors from regular traffic, if any. Water tanks shall be constructed to facilitate draining of the tank and overflow from tank by gravity as far as possible. Manhole cover shall be adequately raised above surrounding ground level to prevent entry of surface water into the tank. Preferably, water tanks shall not be constructed under car parks, garages, etc. In unavoidable situations where water tanks are constructed below ground, suitable size submersible pumps may be part of the permanent installation to facilitate drainage emptying of the tank.
Wherever possible, water tanks shall be constructed with a common wall with pump room or plant room. The floor of the plant room shall be below the base of water tank to facilitate flooded or positive suction to the pump. In such situations, draining of the tank, overflow from tank, monitoring of water level in the tank, etc. can be easily achieved. Quantum of storage required shall be based on professionals' judgment in each instance. The general practice is to provide water requirement of 1 to 2 days in low level tanks and up to 1 day storage in high level tanks where gravity water distribution systems are considered. Where different sources of water with dual piping are provided for flushing and domestic applications, approximately 1/3 of the total storage shall be for flushing and the rest of the storage for domestic application. Due to modern equipment and technologies available, reduction of capacities in high level tanks can be considered to save structural costs of the building. Unless specifically called for in water distribution systems dependent on hydropneumatic equipment with standby power supply, a high level tank need to be considered. Level controllers can ensure automatic refilling of the high level tanks through setting the operation of transfer pumps. Getting on to point number 5, which is water distribution. Water distribution in buildings and premises can be achieved either by gravitational force from elevated storage tanks or by pumping equipment from low level storage. Plumbing codes prescribe a working pressure of minimum 0.5 bar, that is 5 meter water column. Where flush valves are used for water closets, the minimum pressure needs to be 1 bar, which is equal to 10 meters water column. Maximum working pressure stipulated by modern plumbing codes is 5.5 bar, which is 55 meters water column, although most practitioners prefer to restrict the maximum pressure to a lower level. Water distribution system shall be installed such that there should be self-venting and self-draining. Dead ends, vertical loops, etc. shall be avoided. Automatic air vents or such provisions shall be required at all eye points and drain cocks shall be required at the lower points. Water distribution system shall have provision to isolate pipework in segments by providing adequate number of valves on branches serving group of fixtures and also at individual fixtures. In high rise buildings, say exceeding 10 floors, considering floor height of 3 to 3.5 meter, the distribution system will need to be divided into vertical pressure zones to ensure desired minimum and maximum residual pressures, that is pressure at the draw off point. In large complexes consisting of several buildings, a network of external water mains with facilities for isolation in segments may also be necessary. In large network of pipes, whether within individual buildings or for large complexes as described above, main supply pipes in ring formation will be advantageous to balance pressure at various locations, reduce frictional losses and achieve reduction of pipe sizes. On distribution systems with quick acting valves including flush valves, there could be instances of water hammer and the resultant pressure surge. Suitably sized engineered water hammer arresters are installed at appropriate locations. In instances where domestic water is supplied to water bodies, balancing tanks of swimming pools, cooling towers, etc., appropriate backflow preventers shall be considered to prevent backflow and consequent contamination of domestic water system. In determining pipe sizes, below listed criteria are to be considered: the working pressure, velocity and the flow rate. Velocity in pipes should be restricted to 2.5 meters per second. However, when copper pipes are used for hot water distribution, the velocity should be restricted to 1.5 meters per second. While selecting plastic pipes such as CPVC, UPVC, HDPE, PPR, PEX, PB, etc., provision shall be made for pressure derating at elevated temperatures. Pressure rating mentioned by manufacturers of most plastic pipes is at 23 degrees centigrade. Provisions shall be made in pipe work, especially plastic pipe works, for protection from expansion and contraction. Where proprietary expansion couplings, bellows, etc. are unavailable, suitably designed expansion loops shall be considered. Expansion devices shall be provided. The codes have assigned water supply fixture unit valves, what we generally call as WSFU, for various fixtures and appliances normally used in the system. Total fixture unit values will be the cumulative value of all fixture units served by a particular pipe. Flow rates corresponding to fixture units can be determined from the charts available in the code. As far as possible, pipe work shall be installed in plumbing shafts, ceilings, voids, etc., minimizing burying of pipes within the structural elements. Appurtenances serving multi-user points shall be installed in common areas facilitating easy access for repairs and maintenance. This will include large pressure reducing valves, centralized thermostatic mixing valves, common water meters serving number of tenements, etc. Supports spacing for various types and sizes of pipe work shall be based on provisions in the plumbing codes and also manufacturers' recommendations. Closer supports will be required for horizontal runs compared to the vertical runs. Spacing of supports shall increase as the pipe diameter increases. Pipes shall be installed away from structural building elements such as walls, ceilings, etc., keeping a clear space of minimum 40 to 50 mm. Plastic pipes work shall not be constantly exposed to ultraviolet rays unless adequate external protection is provided by means of insulation, protective coating, etc. Water distribution systems shall be subjected to hydraulic tests of minimum 1.5 times the specified working pressure. The system shall retain the test pressure for a minimum of 30 minutes and drop in pressure, if any, shall be within permissible limit. The system shall be flushed and disinfected prior to being put to use. Commonly used method of disinfection is by using chlorine solution of 50 parts per million, that is 50 grams of concentrated chlorine for 1000 liters of water. The system shall be charged with water and the solution shall be added and retained for a minimum of 24 hours. Thereafter, the pipe shall be flushed with clean water. The procedure shall be repeated as required until water collected at the lowest point at the farthest end as distinct smell of chlorine. Where dual piping systems are installed for domestic and flushing water, pipes of different color, appearance shall be used to prevent accidental cross connections during installation or maintenance. Additional protection shall be given by color coding and identification labels as recommended by plumbing codes. Moving on to the sixth point, which is hot water generation and distribution. Depending on the nature of occupancy and quantum of hot water required, one of the following methods or the combination may be adopted for hot water generation. Instantaneous electric water heater storage type, electric water heaters of low pressure and high pressure, gas fired instantaneous water heaters or gas fired storage water heaters, which is either diesel or furnace oil fired water heaters, and solar hot water systems, but not the least with heat pumps. Currently, statutory regulations in many parts of the country mandate usage of non-conventional energy sources like solar energy to meet part of the hot water generation. Hot water distribution system shall generally be similar to domestic cold water distribution system, except that recirculation pipe work shall be added for instant availability of hot water and conservation of energy. The system shall include pipe work, isolation valves, automatic air vents, drain cocks, etc. as described for cold water systems. Additionally, supply and recirculation pipes will require thermal insulation to prevent loss of heat. Pipe work at large centralized hot water generators will also require specialized equipment such as expansion vessels. Large centralized hot water systems will also comprise of ancillaries such as heat exchangers, the mixing tanks, manifolds, circulating pumps, valves, strainers and necessary instrumentation. They can also be integrated with heat recovery available from air conditioning and other systems to conserve energy. Seventh point is safety measures in water distribution. An incorrectly installed water distribution system can have serious implications on health and safety of the users. Hence, preventive measures as described in below points ought to be adopted. Minimum quality of water shall be ensured, especially in potable water, so as to prevent waterborne diseases. Most known communicable diseases as caused by inadequate quality of potable water apart from unsafe sanitation. Prevention of backflow and back siphonage is of extreme importance. Backflow could occur by accidental or unintended cross connections between potable and non-potable water distribution pipes, causing contamination of the former. Precautionary measures as described in the plumbing codes must be strictly adopted. One of the simple measures of preventing back siphonage is the provision of an atmospheric air gap of minimum 25 mm between the tip of the faucet and the overflow level of the fixture, such as a sink. Scalding occurs due to excessive temperature of hot water at the user points, often caused by pressure imbalances at mixers between hot and cold water supplies, especially at showers. Pressure imbalance also causes thermal shocks when flow of either hot or cold water suddenly decreases. Modern plumbing codes stipulate temperature and pressure, that is TNP, balancing mixing valves to prevent such accidents. Thermostatic mixers commonly available and used at user points such as shower mixers or only temperature balancing units, which prevent scalding but not thermal shocks. Centralized thermostatic mixing valves can also be used for a number of user points instead of individual valves at each location. Additional care shall be exercised on solar hot water system, where the temperatures can rise well above scalding temperature. In cases where mixing tank is not provided, a centralized thermostatic mixing valve as described above shall be installed at the hot water outlet leading to the user point. Additionally, metallic pipe work shall be used for a minimum of 2 meters from the hot water outlets in the immediate vicinity of solar panels. Incorrect setting of hot water temperatures in centralized systems can also cause serious consequences such as growth of dangerous Legionella bacteria. Temperatures in the range of 25 degrees centigrade to 51 degrees centigrade assist the growth of this bacteria. A delicate balance needs to be achieved by preventing excessive temperature which cause scalding and low temperature which help growth of Legionella bacteria. Finally, I would like to quote a Sanskrit quote from the Rig Vedas which says, Apo ista maya bhuvastha na urja dadatana mayaranaya chakshase, which means to say, O water, because of your presence the atmosphere is so refreshing and imparts us with vigor and strength. We revere you who gladdens us by your pure essence. Having come to the end of this session on water supply, request you to watch further chapters of a guide to good plumbing practices to get benefited on the crucial aspects of plumbing which is vital to good health. By the way, I am Manjula, Technical Committee Member of IPA, signing off. Have a nice day.